Number 87 is nice just because it already gives us the tree diagram, but it's showing probabilities for a charity calling potential donors by telephone. Each person called is either a recent donor, past donor, or a new person. At the next stage, they either do or do not pledge, with conditional probabilities that depend on the donor class to which the person belongs. Finally, those who make a pledge either do or don't actually make a contribution. So suppose we randomly select a person called by the charity. We are first supposed to find the probability that they contributed. So there are 3 branches that end in contributions. So I'm just going to trace them. Recent donors who say they're going to and then do. Older donors who say they're going to and then contribute. And the new people who say they're going to they pledge to do it and then they actually do. So it's either this or this or this. We're just going to sum those branches of probabilities. So for part A, so the probability of contributing, I could write this all out. I really don't want to. But this is equal to the probability of contributing given there's a recent donor who pledged. I'm just going to multiply them. So 0.5 times 0.4 times 0.8, that first branch. Or it could have been 0.3 times 0.3 times 0.6, the second branch I highlighted. Or it could have been 0.2 times 0.1 times 0.5. So I'm going to multiply and then sum those. And when I say I mean I already did it. And I got a 22.4% chance. Which means there's a 0.224 probability that a potential donor contributed to the charity, just in general. So then part B is a different question. Part B says, given that they contributed, I already know now the person I chose contributed. I want to find the probability that they're a recent donor. So I'm going to do it down here. So part B, we're finding the probability that the person is a recent donor, but I already know they contributed. Now, there are lots of branches that end in contributions, but I can't work backwards. We have to use our conditional probability formula, which says you find the probability of recent and contributed to the 2 events happening together, and then you divide by the probability that the conditional events occurred. So that top one is one we actually already highlighted. A recent donor who contributed. That's the product of 0.5 times 0.4 times 0.8. Then we divide by the contributions, which we already found in part A, which means that conditional probability is, it'd be 0.16 divided by 0.224, so it's 0.7143. So if I already know they contributed, about a 71% chance that they were a recent donor, which makes sense. This is basically saying I'm limiting myself to just the contributed people, and of those people, I'm putting in the numerator essentially the probability that they were the recent people. Because they could have been recent, they could have been new donors, whatever.